Okay, I'm in Belarus doing some testing with one of my pink motor generators. I have pickup winds around the motor coils, but I connected the pickup winds in series to the motor coils to raise the impedance. And I did it to the upper one and the lower one. There's the two motor coils with a rotor going between. So I have the highest impedance possible. I'm running on less than 10 milliamps and the meter is showing 0 because it's less than 10 milliamps and only 7.54 volts DC. And I'm using these solid state relays right here. And you see, they say they go to 480 volts DC, 20 amps. And these are really nice because the trigger side's totally isolated from the load side. But they're kind of slow compared to like a MOSFET. But anyway, so I'm using those right now. And I'm chopping at the high and the low of the coil. I'm using two that simultaneously switch. One will switch the into the coil, one will switch the out of the coil. And I'm doing this because when I feed back power, I need to have the ground disconnected or there's going to be problems. So, and you see I have 4. I'm going to do 2 firing 6 times a revolution, 2 firing 6 times a revolution, but I'm not doing that right now. I am just testing the back EMF, recoil, flyback, collapsing field energy, whatever you want to call it. And I'm filling this cap down here, and it's 600 UF cap. Now I'll get to the heart of the thing here. Usually I connect the steering diode, this very fast steering diode, and I connect it to the MOSFET's drain, and then to the capacitor, and the other side of the capacitor goes to ground, common ground. And that's kind of the way everybody does it. And so you collect the collapsing field that way. But I'm doing something different here. When I do it like that right now, I'm not getting much. I don't know why. Maybe it's the two high and the low of the coil being switched at once with the 2 solid state relays. But instead of doing the drain of the MOSFET, I go over to the input power of the whole thing, the 7.4 volts coming from the battery, the little battery, 9-volt battery, and I connect the diode there, not at the drain of the MOSFET or the input to the coils, input to the solid state relay, which would be like the drain of a MOSFET, because I'm running through the coil first, coming from the power, and then it goes into the switching. So I'm switching at the low side of the coil, usually. Now I'm switching at the high and the low. But anyways, watch this. This is what's interesting. Sorry, it took me 4 minutes to get here. So, I'm running on practically nothing, 7.6 volts, and we're going to see what this cap fills up to, how quickly and what happens. Okay, so first of all, I'm just going to touch this here and watch the amps go up. and it fills the cap. It's going to be filling the cap when I touch this, and amps will go up to about 0.1. Okay, so now I have just filled the cap. There's proof of that. Now, what I want to show you is what does the cap fill up to. And this is what's interesting. It fills up to about 12 or 13 volts very fast. So I'm going to put the voltmeter on the cap. And the other side of the voltmeter is over here. Okay, so when I put this here, I now have the voltmeter hooked to the capacitor to see how much it fills up. So you already saw that the amps goes up to 0.1. That's how much energy it takes. And now I'm going to take this steering diode and hook it where I was saying I'm hooking it now, which is not how I've ever done it before, but it seems to work much better this way. So that's what's interesting. Okay, do both at the same time here. When I touch this right here, when I touch this to that right there, the cap's going to fill up and you'll see the voltage go up. Okay, I'm going to go like 3 seconds. 1, 2, 3. Yeah, that's pretty good. It's gone way over. And now I'm going to hold it there, and you can see it slowly climb. And that's an indication is that you are collecting the back EMF spike, the collapsing field spikes. See, it's going up. And so this is a 600 UF cap. So that's how I'm going to be filling 2 caps. My grand design of this thing, I'm going to shut it down. My grand design of this thing is, I did this in previous videos, 6 times the blue lines, there's a little magnet, trigger magnet, trigger magnet, trigger magnet, and then there's kind of a red line in between, trigger magnet, trigger magnet. And so there's 6 of these blue lines, 6 trigger magnets that's going to trip this Hall effect.
Did you finish your pancake?
Yeah.
Oh, sorry.
And 6 trigger magnets that are triggered by, that trigger this Hall effect. So the idea is there's going to be one Hall effect trips these 2 to fire the coil, and then these, the other Hall effect does these. So I've kind of split it in 2, the motor coil impulses. And that's because I want to have 2 capacitor banks independent of each other. One fills up with the back EMF from like this coil, and then the other one fills up with the back EMF with a lower coil. Okay, so it's kind of like two separate things going on here. And then I have one of these solid state relays controlled by this little trigger magnet here will go past this Hall effect and knock this solid state relay into the opposite cap bank. And then that little trigger magnet will trip this Hall effect and knocks this and trips this relay to knock the power collected into the opposite capacitor bank. So idea is one, this will fill up and then it fills up this. This will fill up and it'll fill up this. This will fill up and it'll fill up this. That's how it's going to loop, if it loops. And I know you lose half of it when you dump one into the other, but you still have half left when that happens. And so it's possible this is going to work. I don't know what percentage of possible, but that's what I'm doing, and that's the grand design. So what I just did is figuring out the best way to fill up the cap banks with the collected collapsing field flyback back EMF energy. And that was pretty good how it went up to 12 and I'm running on 7. So now when I dump one into the other, it's gonna, you know, if I have like 12 in there, now I'll have 6, and 6 is good enough and to run this thing. So we'll see how it goes. But this is interesting that I'm connecting the steering diode, the flyback steering diode. I put it right at the input, right where the positive of the battery goes. I put it there. So this diode's actually spanning with a capacitor in between. It's spanning the input of the motor, the in and the out. So, and that sure seems to be a good way to do it because it's working the best. So, I guess that's it. 12 minutes. Sorry about that. Thanks for watching. Okay, see you later.